Okay, so get this. You sent us a huge GE topic, AI and the environment.
Wow.
You've got reports, articles, even some academic papers, all thanks to Jörg-Owe,
Yeah.
who compiled all this research for us. I mean, we're talking energy consumption, resource drain.
Yeah, the whole shebang.
The whole shebang, yeah.
It really is fascinating how AI is both a potential environmental hazard and a powerful tool for creating solutions, you know?
It's a real paradox.
Yeah.
To understand the impact, we really need to get specific, I think.
Yeah.
For example, you sent in some research highlighting how data centers, like the backbone of AI,
Right.
consume a huge amount of electricity, right?
Yeah, a huge amount. Something like 1 to 1.5% of global usage.
Wow.
Yeah. And to put that into perspective, training a single large AI model can have a carbon footprint equivalent to 284 tons of CO2. That's like running 5 cars for their entire lifespan.
5 cars, that's a pretty stark comparison.
It is.
It really highlights the energy intensity of AI. And it's not just the energy use. Cooling those data centers requires vast amounts of water, often drawn from areas already facing water stress.
Absolutely, yeah. In Virginia, for instance, where data centers are concentrated, water usage has increased by almost 2/3 in just a few years.
Wow.
It's a significant environmental concern.
Okay, so we've got this huge energy demand and water consumption tied to AI infrastructure. But the research you sent also dives into the materials used to build AI tech, and that's a whole other layer of complexity.
Exactly. AI relies heavily on critical minerals and rare earth elements, and the extraction of these resources often comes with significant environmental and social costs. Mining practices can be unsustainable, leading to habitat destruction and pollution.
So it's not just about the operational footprint of AI, but also the entire life cycle of the technology,
Right.
from the materials used to its eventual disposal.
Precisely, yeah. We need to consider the entire picture to understand the true environmental impact of AI. And speaking of the bigger picture, this is where things get really interesting, I think, because AI is also being used to address some of these very environmental challenges.
Yeah. The research you sent highlights how AI is being used to improve climate change models
Right.
and even manage the increasingly complex power grid with all the renewable energy sources coming online.
That's right. One specific example is how AI is being used to predict energy demand and supply in real time. This is essential for balancing the grid and ensuring a smooth transition to renewable energy sources.
So AI is being used to make renewable energy more reliable and efficient. That's a pretty big deal.
It is. And it's not just limited to energy. AI-driven precision irrigation is helping us use water more efficiently in agriculture, which is a major water consumer globally.
Right. This is where AI can tell farmers exactly how much water their crops need,
Right.
leading to reduced water waste and even increased crop yields.
Exactly, yeah.
It's almost like AI is taking on the role of a super efficient farmer.
Think of it as AI giving farmers a level of insight and control that they've never had before. This is crucial, especially as we face the challenges of producing more food with less water.
And the research also mentions how AI is becoming a real game changer in conservation efforts.
Absolutely. What stands out to me is how AI is being used to track endangered species, predict their movements, and even understand how they might react to climate change so we can better protect them.
It's almost like AI is giving conservationists a new set of eyes, allowing them to see and understand things that were previously impossible. But alongside all this potential for good, the research you shared also highlights some of the limitations and potential downsides of AI, right?
Yes, it's important to acknowledge that. One of the biggest concerns is that AI models can be biased, and this bias can actually undermine conservation efforts.
Hold on, how can bias be a problem in conservation?
Well, imagine an AI model being trained on data that doesn't fully represent a certain species or ecosystem. The AI might make inaccurate predictions or recommendations that could harm the very environment it's supposed to protect.
So it's like using a flawed map to navigate a complex terrain. You could end up lost or even worse off than before. That raises a really important point about transparency in AI development.
Absolutely, yeah. We need to understand how these AI models are built, what data they're trained on, and how their decisions are made. Transparency is crucial if we want to ensure that AI is used responsibly for conservation. And then there's the question of data privacy. Who has access to all the data being collected for these environmental AI applications?
Right, it's a bit of a double-edged sword. On one hand, we need data to train these powerful AI models.
Right.
But on the other hand, we need to ensure that this data is being used ethically and responsibly.
It's a delicate balance.
Yeah.
And then there's the whole issue of AI's own environmental footprint, which seems almost paradoxical given its potential to address environmental challenges.
It's like we're trying to solve one environmental problem by creating another. We've talked about the energy consumption of AI, but the research also mentions how the production and disposal of AI technology contribute to electronic waste, another growing environmental concern.
That's right, yeah. The materials used to build AI hardware often contain hazardous substances that can leach into the environment if not disposed of properly. It's a reminder that the life cycle impact of AI needs to be considered from start to finish.
So we've got this complex interplay between the potential benefits and the potential drawbacks of AI when it comes to the environment. It's not a simple black and white issue, is it?
Not at all. It's a nuanced conversation, and that's what makes it so fascinating. It's not about demonizing AI or viewing it as a silver bullet. It's about understanding the complexities and making informed decisions about how we develop and deploy this technology.
Well said. And on that note, let's take a closer look at some of the efforts being made to make AI itself more sustainable. The research you sent mentioned some interesting developments in that area, right?
Absolutely. There are some exciting innovations happening, particularly in the field of AI hardware and software optimization. One of the most promising areas is the development of more energy-efficient AI chips.
Okay.
Traditional computer chips are not optimized for the types of calculations that AI requires, so a lot of energy is wasted.
Right. So it's like trying to run a marathon in flip-flops. You can do it,
Exactly.
but it's not going to be very efficient.
Exactly. But now companies are designing chips specifically for AI workloads, and these chips can perform the same tasks using significantly less energy.
That's a pretty big deal.
Yeah.
It's like swapping out those flip-flops for a pair of high-performance running shoes.
Right.
What about the software side of things? Are there ways to make AI algorithms themselves more energy efficient?
Absolutely. Researchers are developing new algorithms that are more computationally efficient, meaning they require less processing power and therefore less energy to run.
So it's like streamlining the code, making it leaner and meaner. And this ties into another concept you mentioned earlier, edge computing. Can you remind us what that is and why it's relevant here?
Of course, edge computing is essentially about bringing AI processing closer to the source of data. Instead of sending all the data to a central cloud server for processing, we can process it locally on devices like smartphones or even sensors.
So instead of having one giant AI brain in the cloud, we'd have lots of little AI brains distributed throughout our devices.
Exactly. And this can be much more energy efficient because we're not constantly transmitting huge amounts of data back and forth. Plus, it can also improve privacy and security because the data is not being stored in a central location.
That makes a lot of sense.
Yeah.
It's like having a decentralized AI network, which is more resilient and efficient. But even with all these advancements in hardware and software, there's still the issue of our own AI consumption habits, right? We can't just rely on technology to solve the problem. We also need to be more mindful of how we use AI.
Absolutely. We've become so accustomed to AI-powered features and services that we often don't even think about the energy they consume. Personalized recommendations, targeted advertising, facial recognition, all of these things add up.
So it's about being more conscious of our AI footprint, just like we're trying to be more conscious of our carbon footprint.
Yeah.
Maybe we need an AI calorie counter that tells us how much energy our digital habits are consuming.
That's an interesting idea, yeah.
Yeah.
It could certainly help raise awareness, but ultimately it comes down to making informed choices. Do we really need that personalized newsfeed constantly updating? Is it worth the energy cost? These are the questions we need to start asking ourselves.
It's about finding that balance between convenience and responsibility. But getting back to the research from Jörg-Owe, we've talked a lot about how AI can be used to address environmental challenges. But the research also highlights how AI is being used to make resource extraction, particularly mining, more sustainable.
Yes, that's a really exciting area of development. AI is being used to optimize mining operations, reduce waste, and even discover new mineral deposits in a more environmentally responsible way.
Can you give us some specific examples of how this is being done?
Certainly, one area where AI is making a big impact is in mineral exploration. Traditionally, finding new mineral deposits has been a very resource-intensive process involving extensive drilling and surveying. But now AI is being used to analyze geological data, satellite imagery, and even historical mining records to identify promising areas for exploration.
So it's like AI is giving geologists a superpower, allowing them to see beneath the surface and pinpoint the most likely locations for mineral deposits.
Exactly. This can significantly reduce the amount of exploratory drilling required, minimizing the environmental impact and saving mining companies time and money.
That's a win-win situation.
It is.
And the research mentioned a company called Cobalt Metals that's using AI for mineral exploration.
Yeah.
Can you tell us more about them?
Cobalt Metals is a fascinating example of how AI is changing the mining industry. They're using AI to analyze vast amounts of geological data to identify potential sites for cobalt deposits, which are crucial for electric vehicle batteries.
So they're using AI to help power the clean energy transition. That's pretty amazing. But how does their approach differ from traditional mining practices?
Cobalt Metals' approach is much more targeted and data-driven. They use machine learning algorithms to analyze data from various sources, including soil samples, satellite imagery, and geophysical surveys, to pinpoint the most promising areas for exploration.
So instead of just digging around randomly, they're using AI to guide their exploration efforts.
Exactly, and this targeted approach means they can minimize the amount of land they disturb and reduce the overall environmental impact. Plus, it increases their chances of finding high-grade deposits, which is important for ensuring a sustainable supply of these critical minerals.
It sounds like Cobalt Metals is a great example of how AI can be used to make mining more efficient, more profitable, and more sustainable. But what about the actual mining process itself? Can AI be used to make that more environmentally friendly?
Oh, absolutely. AI is being used to optimize various aspects of the mining process, from drilling and blasting to ore extraction and waste management.
Can you give us some specific examples?
One example is the use of AI-powered autonomous vehicles in mines. These vehicles can operate without human intervention, which not only improves safety, but also reduces emissions and fuel consumption.
So it's like having self-driving trucks hauling ore out of the mine.
Exactly, and AI is also being used to optimize blasting operations. By analyzing geological data and using predictive models, AI can help determine the most efficient way to blast rock, reducing the amount of explosives needed and minimizing environmental damage.
It's incredible how AI can be applied to so many different aspects of mining.
Yeah.
But even with all these advancements, there are still challenges to overcome, right? The research mentions some of the limitations of using AI in mining.
That's true. One of the biggest challenges is the availability of high-quality data. AI algorithms are only as good as the data they're trained on, and in the mining industry, data can be scarce, inconsistent, or difficult to access.
So it's like trying to bake a cake without all the ingredients.
Yeah.
You might end up with something that looks like a cake, but it's not going to taste very good.
That's a good analogy.
Yeah.
And another challenge is the need for specialized expertise. Developing and implementing AI solutions for mining requires a unique combination of skills in data science, mining engineering, and software development. Finding people with this expertise can be difficult.
So it's not just about the technology itself, it's also about having the right people to develop and deploy it effectively. And the research also mentions concerns about the potential job displacement that could result from increased automation in mining.
That's right. It's important to acknowledge that as AI becomes more sophisticated, it could potentially automate tasks that are currently done by human workers.
So it's a classic case of technology disrupting the workforce. But couldn't AI also create new jobs in mining?
Absolutely. As the mining industry adopts AI, there will be a growing demand for skilled workers who can develop, implement, and maintain these systems. There will also be new roles emerging that we can't even imagine yet.
So it's not necessarily about jobs disappearing, but rather about jobs evolving. And it highlights the importance of education and training to prepare the workforce for these changes. But even with all these potential benefits, there's still a level of skepticism and resistance to AI in the mining industry, isn't there?
Yes, there is definitely a degree of hesitancy, and it's understandable. The mining industry is very traditional, and change can be slow. There are concerns about the cost of implementing AI, the reliability of these systems, and the potential impact on existing workflows.
So it's a matter of building trust and demonstrating the value of AI in a way that addresses these concerns?
Exactly, and that's where initiatives like Mineral X come in. Remember, we talked about them earlier.
Right. Mineral X is a program launched by Stanford's Dewar School of Sustainability. It's bringing together experts from mining, government, and academia to explore the role of AI in making critical mineral mining more sustainable.
Exactly. It's a collaborative effort to accelerate the adoption of AI in mining by addressing some of the key challenges and building a shared understanding of the potential benefits.
It sounds like a really important initiative. It's about fostering collaboration and innovation to create a more sustainable future for the mining industry. But shifting gears a bit, the research you sent also touches on another fascinating area, where AI is making a big impact space exploration.
Ah, yes. This is where AI is truly venturing into the unknown, pushing the boundaries of what's possible.
It's mind-boggling to think that the same technology that helps us order pizza is now being used to explore the vastness of space.
It is. AI is playing a crucial role in analyzing the massive amounts of data collected by space telescopes, helping us understand the universe in ways we never could before.
So AI is like our cosmic detective, sifting through the clues from the universe to unlock its secrets. But how exactly is AI being used in space exploration? What are some of the specific applications?
One of the most exciting applications is in the search for exoplanets, planets that orbit stars outside our solar system.
Oh, wow. So AI is helping us find new worlds.
Exactly. AI is being used to analyze data from space telescopes like Kepler and TESS, looking for tiny dips in starlight that indicate a planet passing in front of its star. This is a very subtle signal that would be extremely difficult for humans to detect, but AI can do it with incredible accuracy.
That's incredible. It's like AI is giving us a new set of eyes to see the universe.
Yeah.
But finding exoplanets is just the beginning, right?
Sure.
AI is also being used to study these planets and determine if they might be habitable.
That's right. AI is being used to analyze the composition of exoplanet atmospheres, looking for biomarkers like oxygen and methane that could indicate the presence of life.
So AI is helping us answer one of the biggest questions humanity has ever asked. Are we alone in the universe?
It's a truly mind-blowing possibility. And AI is also being used to explore our own solar system.
Oh, I've heard a bit about that. Tell me more.
Well, think about all those rovers and probes we've sent to Mars and other planets. They're collecting massive amounts of data images, sensor readings, you name it.
It's a data feast from outer space.
Exactly.
Yeah.
But there's so much data that it would take humans forever to analyze it all.
AI to the rescue.
You got it. AI is being used to sift through all that data, looking for signs of past or present life, identifying interesting geological features, and even helping plan future missions.
So AI is like a super smart explorer helping us navigate the unknown.
Precisely. And it's not just about exploration. AI is also playing a role in protecting our planet from space threats. Remember those asteroids we talked about earlier?
Oh, right, the ones that could potentially wipe out life on Earth.
Well, AI is playing a crucial role in tracking those asteroids and predicting their trajectories.
So we can avoid a real-life Armageddon scenario?
Hopefully, AI is helping us identify potential threats and giving us time to develop strategies for deflecting or destroying dangerous asteroids.
That's reassuring. It's like having a cosmic guardian angel watching over us. But beyond protecting us from asteroids, AI is also being used to push the boundaries of space travel itself.
That's right. One of the biggest challenges of space travel is the vast distances involved. It takes years, even decades, to travel to other planets in our solar system, let alone to other star systems. But some scientists believe that AI could hold the key to overcoming these limitations.
Okay, so how can AI help us travel faster through space?
Well, it's not necessarily about traveling faster in the traditional sense. It's about finding more efficient and intelligent ways to navigate the complexities of space.
Can you give us some specific examples?
One idea is to use AI to design and control spacecraft that can autonomously navigate through space, making real-time adjustments to their trajectory based on changing conditions.
So instead of having humans remotely piloting the spacecraft from Earth, we'd have AI systems making decisions on the fly.
Exactly. This would not only be more efficient, but it would also allow us to send spacecraft on missions that would be too dangerous or too long for human crews.
That's amazing. It's like having AI captains steering our starships.
It's a pretty exciting prospect. And another idea is to use AI to develop advanced propulsion systems that could allow us to travel much faster than we can today.
What kind of propulsion systems are we talking about? Warp drive?
Well, maybe not warp drive just yet, but scientists are exploring concepts like fusion propulsion, which would use the energy released from nuclear fusion to power spacecraft. And AI is playing a key role in designing and simulating these systems.
So AI is helping us unlock the secrets of nuclear fusion, which could potentially revolutionize space travel. But even if we can develop these advanced propulsion systems, there's still the challenge of keeping human crews alive and healthy during long-duration space flights.
Absolutely, and this is another area where AI could play a crucial role. AI could be used to monitor the health of astronauts, diagnose and treat illnesses, and even personalize their environment to optimize their well-being.
So AI could be like our onboard doctor and therapist, keeping us physically and mentally healthy during interstellar voyages.
Precisely, and AI could also be used to automate many of the tasks involved in maintaining a spacecraft, freeing up astronauts to focus on scientific research and exploration.
It sounds like AI could be the key to making long-duration spaceflight not only possible, but also more comfortable and productive. But beyond the practical applications, AI is also changing the way we think about space exploration.
That's right. AI is forcing us to ask some really fundamental questions about what it means to explore, what it means to be human, and what our place in the universe might be.
Those are some big questions. It sounds like we've just scratched the surface of this topic.
We have the intersection of AI and space exploration is a vast and rapidly evolving field. But the research you sent from Jörg-Owe has given us a fascinating glimpse into the possibilities.
It's been an incredible journey from the depths of minds to the vastness of space, and it's clear that AI is playing a transformative role in both of these realms.
Absolutely. AI is helping us understand and manage our planet while also pushing the boundaries of human exploration and discovery. It's a truly remarkable technology.
Well said, and on that note, we'll wrap up this deep dive. Make sure to check out the show notes for links to all the sources we discussed today, and join us next time for another deep dive into the world of ideas.
Until then, stay curious.
Yeah, it really is incredible to think that AI is helping us explore the cosmos, and might even be the key to finding life beyond Earth. But what's equally fascinating is how AI is changing the way we understand and manage our own planet, particularly when it comes to resources like minerals.
You're absolutely right. We often talk about the energy consumption of AI, but we can't forget that AI also relies on a complex supply chain of raw materials, many of which are extracted through mining.
And as we discussed earlier, mining can have a significant environmental impact. But the research you shared from Jörg-Owe highlights how AI is being used to make mining itself more sustainable. It's like using AI to mitigate the environmental footprint of AI.
Precisely. And it's not just about reducing the impact of mining, it's also about using AI to find new and more sustainable ways to access the resources we need for a clean energy future.
That makes sense. If we're going to transition to electric vehicles, solar panels, and wind turbines on a large scale, we'll need a reliable and sustainable supply of critical minerals like lithium, cobalt, and nickel.
Exactly. And AI can play a key role in finding those resources not only in traditional mining locations, but also in unconventional places like the deep sea or even asteroids.
Asteroids, that sounds like something out of science fiction.
It might sound far-fetched, but asteroid mining is becoming a serious area of research and development. Asteroids are rich in valuable minerals, and some scientists believe that they could provide a more sustainable source of resources than traditional mining on Earth.
I can see how that could be appealing, especially if we can minimize the environmental impact of mining in space. But how would we even go about mining an asteroid?
That's where AI comes in. AI could be used to identify and characterize suitable asteroids, design and control robotic mining equipment, and even process the extracted materials in space.
So AI could essentially automate the entire asteroid mining process. That's pretty remarkable. But even if asteroid mining becomes technically feasible, there are still a lot of ethical and legal questions to consider.
Absolutely. Who owns the resources in space? How do we ensure that asteroid mining is conducted responsibly and sustainably? These are complex issues that will need to be addressed as we venture further into space.
It's a reminder that technology is only part of the equation. We also need to develop ethical frameworks and international agreements to govern our activities in space.
Well said. And it's not just about space, it's about how we approach resource extraction on Earth as well. We need to shift from a mindset of exploitation to a mindset of stewardship.
I like that, a mindset of stewardship. It's about recognizing that we're part of a larger ecosystem and that our actions have consequences. And AI can be a powerful tool for helping us make more informed and responsible decisions about how we manage our planet's resources.
I couldn't agree more. It's about using AI to create a more sustainable and equitable future for all.
Well, this has been an incredible deep dive exploring everything from the environmental impact of AI to the potential of asteroid mining. It's clear that AI is a powerful force shaping our world, and it's up to us to ensure that it's used for good.
Absolutely. The future of AI is in our hands.
A huge thank you to Jörg-Owe for compiling the research that made this deep dive possible. And to you, our listener, thank you for joining us on this journey. We hope you've learned something new and that you'll continue to explore the fascinating world of AI with us. Until next time, keep those brains buzzing.